Welcome back to this section of AI for healthcare, and just kind of change this AI for healthcare. And what we're looking at is the molecular virology, and go through a few topics around molecular virology. So I'm sure you got a bit of an idea around in the previous lecture we spoke about what are the viruses that are out there, what do we know about this, and since when? The technological advances in modern virology, what have we learned about these viruses? And obviously the interrelationship between the virus research, cancer research, neurobiology, and immunology. What have we learned so far? Are these effective enough as we move forward? And what kind of strategies could be there? The underlying antiviral chemotherapeutic agents and probably other techniques to basically fight this. And the challenges that the modern virology faces is probably the most important. Today we are looking at, we've learned a lot in the last 100 years, but how do we move forward? So we're going to just go quickly into a few lecture series. So we're going to go into the virus itself. What is it? So it's a definition, structure, and classification. So classification. And next, once we've done that, then we're going to go and take a look at how it proliferates. So virus proliferation and replication, how it replicates. And then we are obviously going to look at the part that makes the virus, our enemy, is the pathogenesis. Pathogenesis and the cell damage that it causes, destroying our body, which obviously is, traumatic. Its transformation, the next topic could be transformation and, cancer-specific carcinogenesis. So how does it develop? Can it develop? It does obviously develop oncogenic properties that makes it, live amongst us and becomes, a chronic sort of disease, which we obviously do not want. Immunology is an important topic as well. I'll go deeper into these guys. So cytokines, chemokines, and interferons are our friends. These are the guys who are unleashed when you have a viral or a virionic particle, which is this virus particle, entering into our body, and we need to find a way to fight this. There are techniques to fight that, obviously. So the cure could be chemotherapy, and obviously vaccines are the better way to prepare ourselves against such epidemics. Epidemiology, talking about epidemics, is the next topic, obviously. Epidemiology, and obviously the viral level. So epidemiology is the next topic. Let's take a look at what the other I have already written. So I have it here as well. So I guess epidemiology, and I hope cancel. So I need to. Yep. So basically this, so epidemiology and the mathematical models associated with epidemiology is definitely makes a lot of sense, and just want to understand does it make sense to still use these methods, SIR or IME, or are there other techniques available that we should be able to apply in this sort of modern world with machine learning and deep learning and all the advances that we've had in the last decade. So what is possible? The virus evolution itself, the next topic, makes a lot of sense to understand. And the laboratory methods, the lab methods for detecting viral infections. There's a lot of other things you can, I mean, if you go deeper into molecular biology, and this is not something we are doing because we are not teaching or learning molecular biology to the deepest core, you will understand that there are many things around viruses like single-stranded positive sense RNA genomes and single-stranded non-segmented negative sense, so positive sense, negative sense. We'll explore that just at a high level, but not go any deeper into this. We may explore, depending on if we still are excited about this topic, I would like to kind of look at the transmission electron microscopy. So transmission electron microscopy, and understand in virology, obviously in virology, and understand, so how do you, what are the fundamentals, the preparation methods, and diagnosis. So I mean, diagnostics is super important, and I think we can just call it diagnostics. So I'm thinking, 4 or 5 lectures, we get a high level understanding, and I have prepared already a bunch of slides here to go into the next chapter, which is what are viruses, its structures and classification, and then we're going to go into these topics, and once we're back, then go back into the other theory topics, understand a little bit from proliferation, how does it sort of expand and damage our body, its transformation into turning into a carcinogenic, developing carcinogenic properties, immunology, chemotherapy, epidemiology, which is on the next chapter, and then move from there.